Hey folks, we are at question number 208 tonight. The point of these questions and answers are basically if you are getting ready for a DevOps interview, technical interview, you uh, I would like you to get enough width and depth in different topics that are necessary to pass your DevOps or SRE technical interview. That's why I am doing these videos. If you're new to the channel, please subscribe. It's nothing for you, but it's actually a big deal for my channel. So I would really appreciate that. What I did, I don't know, maybe a year ago or so, I took 35 job descriptions from LinkedIn for DevOps and put together, basically sorted all the keywords that came up and sorted them in order so you know which ones are more important. So as you can see, cloud or AWS, these things are the most important. It's basically the bread and butter of DevOps. And stuff like system design is number 15. Although the bottom ones are not as important, they're not negligible. You do have to study. You do have to spend some time studying them. Of course, spend more time on the first 5 or 6 topics, time and energy. So today we are at topic number 4. Now, as you can see, number 4 is pretty high up there because, especially if it's a pure SRE type role as opposed to DevOps, and you should know the difference, then you're supposed to have coding experience, a real coding experience, not just YAML files or simple Terraform, real coding experience. You're supposed to have at least some experience with that. So this particular question might come along if the interviewer is looking for somebody who has had software development experience. So on to the question. The question today is, can you explain the O log n complexity, and can you provide an example of such algorithm? So this is all about algorithms in code. So if you have taken even a data structure course, you would run into this. So that's why it's kind of simple in that way. But again, in interviews, people are not looking for in-depth things because that is not a good expectation of people during a live interview. But if we have experience, you would know what this means. So before I get to the answer, real quickly, Floyd Spencer is my career advisor. This is not an ad, but he is always giving out 1 hour free session to anybody who's in the job market. So go ahead and sign up. It will help you. So first of all, the complexity of an algorithm has to do with how much time you think that algorithm will take based on how large the input is. So let's say that input number is 10, it runs in 1 milliseconds, right? But when the input number is, let's say, 1 million, how does it grow? Because at that scale, it makes a big difference. It can be a real slow application if it doesn't scale very well. So that's the idea of a complexity of an algorithm. So n log n complexity means that if as your number of input n grows, the time taken by your algorithm when executed will grow in proportion to n times log n complexity. So it's in between n linear time and n squared time. It's somewhere in between. Now, almost all the sorts these days are n log n. I don't think anybody has figured out a quicker way than that. So merge sort, heap sort, quick sort, they're all n log n. And if you're using Golang for language, for example, all the sort libraries that we have, they're all also of n log n complexity. Again, the idea is as your input number grows, that's how slow your code is going to be. So n log n is better than n square, and but still not as good as linear and complexity. So that's what that means. Okay, so yeah, if you have any questions or if you want me to cover a particular topic, find me on LinkedIn or just leave a comment below, and I will see you at the next one.